Hi everybody. In this video that you're going to see, I'm very sorry. I've done damage to my mobile phone. It's done some serious damage. The effects of the electromagnetic waves have done something to the phone. Yeah, good morning everybody. It's DC again here. Under the heading Electrons Don't Exist, I'd just like to bring your attention to the hairpin setup. That's Nikola Tesla's hairpin setup, which he used to take with him to show students the particular example of what was happening with the hairpin circuit. In other words, it was a key item in Tesla's teaching. So I've been asking myself some key questions. Why did Tesla used to call it the Stout bar experiment? And also, why do capacitors increase the volts? And I've come to realise that what's going on at the capacitor, and particularly at the spark gap, is it's dielectric discharge. That's it. It's dielectric discharge. Call it lightning or whatever. In a circuit that is oscillating, so it's an AC circuit, what you've got at the spark gap is a discharge. So it's a discharge which is sort of flipping, it's sort of rotating, but it's a discharge. That's all that's happening there. No electrons, just a discharge. And if we focus in at the spark gap, I hope you can see this all right. The thing that's happening at it's all happening at this point here, but there's no electrons at the spark gap. There's no electrons, there's just a discharge, and of course that gives a magnetic flux. So it's just a discharge, and then of course you've got radials going out, but you've got waves, but you've got dielectric waves, which in my opinion can be faster than the speed of light. So you've got scalar waves going out. Tesla particularly said that what was happening at the spark gap, please take note of this, what was happening at the spark gap was an event. So now, hopefully, I'm going to take you over to my setup here, which I'm using the Morin motor setup, which if you've been watching my other videos before, it's just a motor, which is a DC motor, which is connected to a washing machine pump, which is basically an alternator, goes through a capacitor, and then to a transformer, which is 10,000 volts, but that's increased. I've increased it. I've got in the region of 40,000 to 50,000 volts going through it. Got a couple of high capacitors here. I'm not sure of the capacitance on them, but it's very high. I've got a few things dotted about here. So what you've got here is basically the Stout bar experiment, and we've got the spark gap here. So what you've got going on here is exactly what was over on the whiteboard. So I'm going to switch it on. What I'm going to do, it gets a little bit noisy. I'm going to short out here, this wire here will short out the two capacitors. When I short them out, obviously it's going to make some sort of effect. Just note what happens with the effect when I short them out. Okay, I'm going to switch it on. You can see the power consumption settings. Okay, so we've got it on. There's the spark gap. I've got a 35 watt sodium lamp here, and we've got the two Stout bars there connected, and they're actually touching the capacitors. Just gonna switch the light out so you can see. Now all that's going on here is dielectric discharge. There's no electrons flowing. It's dielectric discharge, and you can also see it on a tube here that's just laying on. That's not connected, I don't think. It's just laying on there. Okay, right. Yeah, I don't know what happened there, folks. My camera just probably got too near the high voltage there, so it just dropped out. Okay, I'm going to touch. Now, if you notice, yeah, I'm sorry, folks, I got too close. The magnetic waves, electromagnetic waves, knocked the camera out. if you noticed, I'll do it from a distance, I'll do it once more. You can hear the strength of the spark gap and the strength of the flow increase. I'm going to have to switch off now and start another video. Okay everybody, sorry about that, I'm having a few problems with my camera. Dielectric discharge. There's the earth, so you've got, this is soil here, soil. There you've got clouds, yeah. Clouds, and you've got lightning, yeah. You've got positive charges, negative charges. What you're looking at the spark gap is nothing more than that, and whereas you've got one charge like that with the lightning, it comes down, the lightning comes down, bang, or goes up. It can go both ways.